Today we'll have part 2 out of 4 of the Matlab tutorial. Now, before I get into traditional Matlab constructs, my Matlab user interface setup may be different than yours, like you just installed it. So what I've done here is I've told it to restore the default layout. Now, we're assuming it gives like a laptop or desktop version of Matlab. Some of you are not. It's differences, but okay. So the default layout, at least for Mac, is what you see here. So the command window in the middle, and then your list of files in your current directory over here, and then your workspace between your variable over here. And what I like to do is, so if I click on the workspace and I want to, I don't like it to have it here, I like to move it over here, so I can move it around and have it take up the bottom half of this left pane. And there are other windows that are not showing here. So what I like to have is called command history. So I scroll down to command history under there's this layout button here, and then I select dot so that it shows up over here. So these are the last commands that I was running. And what I can do is I can I won't do it now because these commands won't make sense, but I can select commands, and if I wanted to, I could rerun them. So that's a feature that I take advantage of now and then. Like if you don't already have these commands saved, like in an M file or diary. Okay, now another thing is, and we'll see more of this later when we start looking at files, but there's one example I'd like to show you now. Okay. If I have here, we'll talk more about M files later, but if I were to open up one of these, watch what happens in the default layout that Matlab has. So I'm just going to double click on this. And now we're in the Matlab Editor. So anytime you double click on a file over here, at least if it's a plain text file, which a .m file is, it is ordinary text, just a different extension, it opens up the editor. So here you can go ahead and work in your file. But the thing is now, the command window is nice and small, but the editor has taken up a lot of your screen real estate. And I found that generally my students have it set up like this. They just go ahead and use the default setup. And it drives me batty. I'm always asking, can you make a command window bigger? And if I were to open up more files, like I'll pick another one here, but it has multiple tabs for the files that you have open. So I like to have a big command window. I like to see what's going on, and I also like to see what's in these files. I just want it all. So what I do is so something to suggest to you, you might like it better. If I go up here, there's this small down arrow, and I have these options. So in this case, I'm going to choose Undock, and that's going to cause the editor to be moved to a separate window. So now I have all my editing going on over here in this window, and then I can flip back over to the main Matlab window, and I have my big command window again for all time. And now this is the setup that I generally work with. And yeah, I do need to flip between windows, but I'm okay with that under circumstances. Okay. So you see that every single one of these panes here has this arrow where you can select to undock or whatever you want to do. Okay. Close this down. We'll be seeing these files at some point, but not necessarily today. Okay, great. I haven't done that much yet. Right. So now I will start the diary for today's MATLAB session.
I'm not.
Oh, what's up?
Yeah. I accidentally closed space.
Oh, okay. So what you can do, go to layout. Okay, and then click on workspace. Okay, and then click on the arrow over here and choose dock. And now put your workspace back. And you can do that with any of the other windows also, like the files. Okay, so I'll call this tutorial. Today is the 29th. Okay. All right. So now logging is on into this file that I'll post in Canvas after. Okay. Now, last time we saw various mathematical expressions, how to make certain matrices, and then so forth. What I'm going to start with today deals with, yes? Oh. Mission denied. Okay, go over here with the arrow and then click on the black arrow and click on it. No, not up a little bit. This one, yeah. Okay. Change to that folder. The yellow downloads. Yeah. Okay, try diary again. Use the up arrow. Click on hit the up arrow key. And it'll bring that command back. Okay, now hit enter. Okay, so apparently the folder, before you were in a folder where MATLAB is actually installed, and it would not let you write a file into that folder. So that's why now you're in a different folder where you can save a file. But this brings me to this important point. Okay, you can use the arrow keys to bring back your old commands. So here I'm cycling through. This goes back to my prior MATLAB session. So that can save you some typing. Scroll, use the up and down arrow keys to scroll back through your command. And you can see this command I just gave here is now showing down here, added to my command history. Okay. Now, today I'm going to deal with logical expressions. So expressions that have a value true or false. Okay. So the idea is that any non-zero value, any non-zero number is considered true as far as logical operations are concerned. Whereas number 0 is considered false. This is similar to what we see in other programming languages, that 0 is considered false, anything else is considered true. Now we have what are called relational operators, which are what you see in other programming languages: less than, greater than, less than or equal to, greater than or equal to. And then for comparison, we have a double equals, which we also see in other programming languages like C or C++. And for not equals, it's a little different. It's a tilde equals. Because some languages use an exclamation point in equals. Okay. So this is not equal to. This is not one. So a single equals is for assigning a value to a variable. Double equals is for checking whether two expressions are equal to each other. Okay, so as an example, if I do this, 4 greater than 3, so since that is a true, mathematically true statement, it has a value of 1, which is considered true. That's like the default true value. But notice it says logical. So what does that mean? So I use this command from last time, who said prints out all my variables. And so the answer is has a value of 1. It's a 1-by-1 matrix because it's just a scalar value. But notice the number of bytes. Only 1 byte. So logical is 1 byte, which is 8 bits, as opposed to a double precision floating point number. So that's the default numeric type in MATLAB. That's 8 bytes, so 64 bits. For logical, you don't need a lot of storage to indicate if something is true or false. So this is meant to reduce memory usage. And it's flagged as logical just to distinguish it from other numeric types. Showing the comparison operator, so 1 equals 0, so I'm putting in a false statement. So that has a logical value of 0. Unlike other programming languages like C, MATLAB often, but not always, automatically converts numbers as needed. So like, so for instance, okay, I think the try this here. I'm gonna perform the same operation. We're gonna save the value in a variable I'll call x. Okay, so x is equal to 0, and we see that x is 1 byte logical. I'm gonna try this. Now, pi is a special variable in MATLAB. It's equal to pi, 3.14159, etc. So here I'm adding a logical and a double precision floating point number. Let's just see what it does. Okay, so x is equal to 0, but now, what?
Mine stopped at 4 digits.
Oh, yeah.
Mine also stopped it.
Yeah. So so you probably saw this, right?
Mm-hmm.
Yeah. Yeah. The default format is format short, which only shows 4 decimal places. I guess at some point I must have set my default format to long. I don't remember when I did that, but yeah, because I guess that's usually what I want to see. So, everybody good with that? Okay, right. So that's how you go back and forth. So I'll go back to format long for 4 decimal places like right. Like electrolytes. Okay, now, are there any questions about these kind of relational operators, comparison and so forth? Okay, now, next we have logical operators that go hand in hand with these. We have an and, or, not, and also we have element-wise logical operators. So some of these operators are similar to the ones you've seen in other programming languages. So logical and is a double ampersand, so the same kind that you see like in C and C++. We have a logical or, that's a double vertical bar, so that's the same as in both languages. So if I have, for instance, I'll assign x a value 1/2. So then I'm going to do, I've been expressed this together. So x greater than -1 and x less than 1. So given that x is 1/2, this is a true statement. So it shows me that it's true, that it's a value true. Okay. Now, so you can build compound logical expressions using and or if needed. But I want to show you one very important thing about these kind of compound logical expressions. And this comes up in a lot of programming languages. If you're not aware of it, that's on you. These operations, and or, there's a very important programming concept in general beyond MATLAB, and it's called short circuit evaluation. Okay, so what is short circuit evaluation? So as an example, here's a compound logical expression, x or y or z. So x, y, and z could be who knows what. It's not important for this. Okay. Now you know how it is with a logical or. If any one of these expressions, x or y or z, if any one of them is true, the whole thing is true. So evaluation of this expression might be expensive, so MATLAB optimizes it somewhat. So if x is true, well then the whole thing is true. That means as far as determining the value of this expression, there's no need to evaluate y or z. So that means that under short circuit evaluation, if an expression is determined to be true early in its evaluation, the rest of the expression is not evaluated at all. And that's important because what if you were counting on the expressions y and z being evaluated, whether this whole thing turned out to be true or false? Then you're in for a rude awakening. So, like for instance, what if x, y, and z are function calls? So if like y and z represent function calls, x is determined to be true, these functions don't get called. And if you needed it to be, then things might not go the way you expect. Similarly, if I have x and y and z, will it be a situation that would also trigger this kind of short circuit evaluation and stopping the evaluation early because we already know the value? Because here, in the case of x or y or z, if x is determined to be true, then we don't bother with this. So what would be the analogous situation for x and y and z?
If x and y aren't true, then there's no need to check z.
Yeah, so as soon as you find an expression to be false, the whole thing is false. Okay, so the example, if x is false, false, y and z not evaluated. Okay. All right. Okay. The logical not operation is a tilde. So, for instance, if I do 4 greater than 3, but then I want the negation of that, then as expected, I get the value of false, which is probably why MATLAB uses tilde equals for not equal to, instead of different choices in other programming languages. Questions so far about logical operators? Now, there's more operators I can show you that don't really necessarily have counterparts in other languages that deal with the vectors and matrices. So I'm going to make a random vector, and then another random vector, y. So let's, yeah. All right, I'm going to use format short here, just to make this a little easier to read. And I'm going to use this kind of expression, x, y, in square brackets, to put these vectors together next to each other horizontally. So this is x in the first column, and y in the second column, just so you can see what numbers we have. So I'm going to use these vectors to demonstrate what's called an element y.
Different values than what you got.
The reason for that is, so MATLAB, when it generates random numbers, really they're pseudo-random numbers. So it starts with random number generator, some seed. So for example, if you and I started MATLAB sessions and generated random numbers, the same random numbers, we get exactly the same numbers. But I've been running the MATLAB session for longer, whereas yours would have just started a little while ago. So I've already been generating some random numbers and you haven't, so that's why ours are different. But if any of you are following along, like if you just started MATLAB and started doing what I'm doing, then there's a good chance that you're probably getting the same random numbers as each other, but different from mine. Okay, so I'm going to show you an element-wise OR. So that's a single vertical bar. And there's also element-wise AND, that would be a single ampersand, instead of a double bar and double ampersand we saw earlier. So I'm going to show you how to use that. If I do this, x greater than 3/4 and y less than 1/2. Okay, so let's see what it does first, and then I'll explain it to you. Okay, so it's looking for, is the value, so it starts from the first row and checks, is the x value greater than 3/4? In this case, it is. And then it goes to y value. Is a corresponding y value less than 1/2? It's not. So the first element of this comparison is false. Then it goes to the next row. Is the x value greater than 3/4? No, it's not. It's been by short circuit evaluation. For the second row, everything is false. And then we go to the last row. Is the x value greater than 3/4? Yes, it is. Is the y value in the same row less than 1/2? No, it's not. So we got false, false, false. So this element-wise AND operation, or corresponding OR operation, will go through, it's useful for doing element-wise or AND through a vector or matrix. I'll do another. I'm going to make a random matrix, 3 rows and 2 columns. Okay. And, all right. So if I do A greater than, say, 0.6, and A less than 0.8. So let's just see what this does. So the result of this expression is also a 3x2 matrix with logical values, the same size as A itself. So what it did was, this operation examined every single element of A, and it checked, is the element greater than 0.6 but less than 0.8? But the only element of A that satisfied that condition was this one. So that's why in row 2, column 2, we get a 1. Everywhere else, we get a 0. Hold on. When you're doing this kind of expression, because this is a logical matrix, this is also a logical matrix. They have to be the same size when you're using this element-wise AND or operation. Otherwise, it's an error. Yes.
Got all 6 zeros instead of 5 zeros.
Oh, well, okay. So, right, because every single number in this matrix is not in the interval from 0.6 to 0.8. Because, yeah, it's like here, if you look at each number individually, none of them are inside that range. Whereas in my matrix, actually all of these numbers are also outside the range 0.6 to 0.8, except, dang it, except this one. But your matrix did not have any numbers like that. Okay, actually, if I go back to my X and Y example here, okay. if I do the same operation that I did on them before, but then I use an or instead of an and. Okay, so in this case, all true, because in each row, so either the x value is greater than 3/4, or the y value is less than 1/2. So in each row, one of these conditions, at least one of these conditions was true. So that's why we get true, true, true in this case. Whereas with and, it was all false. All right, so any questions about component-wise logical operations? I mean, later we'll learn about loops and such, and you can always, if you're trying to check some condition on all the elements of a vector or matrix, you could always use a loop to do that. But here we have some conveniences that can save some time. In terms of efficiency, though, it may not be much difference. Okay. Now, very important part of MATLAB, working with M files. Like, I can use the edit command. Now, you know what? I'm going to check on something real quick. Don't know if it's available. Okay. Oh, yeah. I should have thought about this, and because I'm about to open up one of my files, but I have not made that file available to you yet. I will post, because here, this is from the last time I taught the class, 2 years ago, and I have all these files posted from back then. And so I will have that after class. Okay. Convenient way. It's not. Okay, I'll have to keep that in mind, like for the other parts of this tutorial, to have these files available beforehand, like if you want to download them. Okay, so I have a prompt. You can use the edit command to open up a file. Now I have it set up so that if a file doesn't already exist, it will create it for me, because that's generally what I want. But the default setting is that it'll ask you if you want that. Okay, so this file that I previously created, sine of x.m. So this is the first example we've seen here of an M file.
Okay, we need to copy that.
Well, I'll post it in Canvas. But as far as what you're doing now, I mean, I'm going to be talking about this for a while, so you're welcome to type it in if you like, but you don't have to.
So type in edit.
Right, but that's up to you. So, okay. Now this is an example of what is called a script M file. There are two types of M files we're going to see. Script files, and then later, probably next class, function M files. Okay, it asks you if you want to create it, so in this case you would say yes. So it'll give you it should give you a blank editor window. Okay, yeah. Right. So there's script M files and function M files. Script M files, you can think of it as a way of getting around using a prompt. You can type commands into a script M file that you might also type at the prompt. But this way you can run the script file all at once and not have to type those things in all the time. I'm going to tell you what's in this file first. I'm going to talk about that. And then I will run this M file. I'll show you how to do that at the prompt. Okay. Now, okay, let's talk about this file. So, okay. What does this code do? First it generates a random number between -1 and 1, because this expression, rand of 1, generates a 1-by-1 matrix, in other words, a scalar, a random number between 0 and 1. But I want it to be between -1 and 1. So I do a scaling and shifting. So if I multiply by 2, I have a random number between 0 and 2. Then I subtract 1, so now it's between -1 and 1, uniformly distributed. So x is my random number. I go ahead and print it out. That's what the disp command does. So disp and so disp function and whatever expression you want in parentheses will display whatever it is. It could be a number, it could be a matrix, it could be a text string, anything. It'll figure out how to display it for you, but without a label. I'll explain what that means in a little bit. And then next we have a first example of a Matlab if statement. So an if statement, if you've seen any of our programming languages, you've definitely seen an if statement. It's meant to execute code based on the result of some condition. So first we check, is x positive? If so, then the code right below the if statement is executed. It's going to print out x is positive. Now, if that is not the case, we come down here and we have else if. So MATLAB else if is one word. So now it's going to try another condition. So x is already found to not be positive. Now we check, is x less than 0? If so, we print out this message, x is negative. And we can have as many conditions as we like. And finally, after all those conditions have fallen through, if they've all turned out to be false, we come down to this condition, the else. And so the only possibility left is not positive, it's not negative, it must be 0. So we print that out. And then we have an end. That marks the conclusion of the if statement. Now, else ifs and elses are optional. I mean, if you only have one condition to check, and you don't want to do anything if it's false, then you just have a plain old if statement. But I want to show you all the different things, like if, else, else if. The else has to be the last clause of the statement. So like you cannot have an else before an else if. So logically that wouldn't make sense. Now, before I run this code, do we have any questions about how the if statement is set up? So notice the name of a file, signofx.m. So now I'm going to go back to the command window and I'm going to run this script. And to do that, I type in its name without the .m. So it's just signofx. And let's see what it does. So it generated a random number between -1 and 1. It goes ahead and prints it out. It happens to be positive, so it prints out the message x is positive. Now, I want to contrast different ways of displaying expressions. So in this case, displaying the random number chosen, I just did disp of x. But if I go over here and change this line, I'm going to comment out this line, and I'm just going to put x by itself, because that will also cause it to print, but it's going to look different. So if I run it again, notice the way it printed out this time. It gives the name of a variable, if it is a variable, and then it prints the value, and there's more blank lines. So the appearance is very different. Whereas you might argue that this is a bit cleaner. So keep in mind as far as how you want your output to be displayed. If I'm debugging code, trying to get it to work, I'll usually use this form of printing because then I can see the variable name.
I got a negative this time.
Okay, well it's random, so yeah. But if I were to continue running this at some point, yep, there's negative.
So cold in here.
For whatever reason, it's getting errors.
Oh, did you type it in? Okay, hold on. Okay,
There we go.
okay.
I had an unnecessary space.
Oh, okay. Oh, the else if. Yep. Yeah, because a lot of languages, else and if are separate words. Okay.
Yeah, it is.
All right. Any questions so far about this statement? I mean, I'm gonna have another example. Now, I have another more involved script file to show you. Enter month year. There's a lot to talk through. I guess more modern speak is a lot to unpack here.
I didn't create.
No, none of you do, but I'll post it in Canvas after. But first, I'm going to go ahead and run it. Okay, so it's called entermonthyear.m. So I'm going to type that in the prompt. Okay, so first it prompts you for the number of a month, 1 through 12. So I'll put in September, so month 9. And then I'll put in the year, I'll see 1969. This is the month and year I was born. And it's going to tell me how many days are in that month. So it's 750 days. Whereas if I do it again, and I put it in, let's say, February of 2020, that's a leap year, so it has 29 days. So, this is what this script does. It accepts as input from the user the number of a month in a 4-digit year, and it determines how many days are in a month by taking leap years into account. Okay. Although I should mention, yeah, there is a exception to the New Year rule about every 4 years being a leap year. I did not take it into account here, and people popped me on that last time. I'm just not doing it. So, so no one give me crap about it. I acknowledge the mistake. Okay, so now I need to go through this and explain how it does what it does.
The whole thing.
Well, I'm going to talk about the whole thing, but you don't have to type the whole thing. But you will be able to access it in Canvas later. Okay. Although, okay, I'm going to check something here in Canvas because even though I've not made it available, I might have it in Canvas. Oh, I do. This is from the last time I taught the class. Okay, so here's what I'll do. I'll go back to the main page in Canvas, and I'll put a link to it. Okay, so here on the main Canvas page, you should be able to see it now.
Got it.
Great. Okay. Is that the only one I'm doing? Oh, there's a couple more. I'll do those when I get them. Okay. Now, first thing we do, we're asking the user for input, and for that we use the input function. So the input function takes as an input argument a text string. Notice that text strings, you use single quotes. I think it might understand double quotes too, but I've just always been conditioned to use single quotes. It definitely works. So whatever text string you put in here in quotes, that's the prompt that will be displayed for the user. So we see when I call script, it prints this out first, and then it's going to wait for the user to type something in and hit enter. So whatever the user types in will be returned by the input function as a return value, and then I can assign that to a variable. So in this case, I'm asking the user for a month, and I'm assigning it to the variable that I've called month. And then I do the same thing for the year. I prompt them for a year. They'll type something in, and that'll be assigned to the variable year. I'm not doing any input checking. I'm expecting them to type a number between 1 and 12. I'm expecting them to type in a 4-digit year. If they're going to type something different, something's going to go wrong, and it will be their fault. So I'm not being very user-friendly in this case. Or I guess, as software engineers often derisively refer to it as, they don't idiot-proof their code. Okay. Now, what I want to do though, I want to display the name of a month. And that's what I do here. Like I entered 9 and I actually print out the text string September. So here's what I do to make that happen. Here, I'm making a matrix of text strings that have the names of all the months. So this is a matrix that has 12 rows, one for each month, and 9 columns. Notice that after January, February, there's always at least one space. It's because I have to make sure that all of these strings have the same number of characters. The longest month name is September. So each one of these strings has to have 9 characters in it. So otherwise it would give me an error. So we have a 9 by 12, a 12 by 9 matrix of characters. All right, so now I have a matrix of month names. So then what I do, to get the name of the month I want, I'm accessing the proper row of the matrix. So we saw this last time. I specify row and column. The row is the number of a month that you entered earlier. So for instance, if I enter 9, value of month is 9, so I'm accessing the 9th row of this matrix, which is September. And I take all columns. I talked about this last time. That's what the comma colon indicates take all columns of this row. So it grabs the entire row. So month name has the name of the month I want. But it also has these pesky spaces. I don't really want that. So Matlab provides a command called dblank. So if I call the function dblank and a text string, it will remove all the extraneous spaces at the end. So now, let's say month name equals dblank month name. I'm overriding month name with the string that has the blanks removed. So now month name holds the name of the month I want to print out, and nothing else. Okay. Any questions so far about the string processing? Next, I have to determine how many days are there in the month provided. Enter value using this statement. So first I check, is the month February? So so is a month equal to 2? So here I'm using a double equals for comparison. That's the most interesting case. So now, knowing that it's February, I need to check if the year is a multiple of 4. And for that I use the rem function. Rem is short for remainder. So rem year 4, what this does is it calls the rem function will divide year by 4 and return the remainder. So if a remainder is 0, that means that year is an exact multiple of 4. That's a leap year. So I set this variable, days, the number of days in the month, equal to 29, else I set it to 28. In that case, it's not a leap year. So this, here we have an if statement inside an if statement. So the inner if statement, determines how many days are in the month, given that the month is February. So now the case of February is handled. If it's not February, there's two possibilities left. So now I have else if the month is equal to April, June, September, or November, then the number of days is 30. And then here I have the text of the one kind of saying about how many days are in each month. And then if none of these apply, if the month is not any of these, then that the else takes care of it. So by this time I know that the month is not February, April, June, September, November. It's one of the 31-day months. So at the end of this whole nested if statement, the variable days will be assigned values, no matter whether it's going to be 28, 29, 30, or 31. So now I have the number of days in the provided specified month. So now I'm ready to display my output. Now here we see two examples of the output. You know, month, comma, year has how many days here and again here. So how do we do that? I use the diff command, and everything you see here in the square brackets, I'm cobbling together a text string from string constants and variables. First, I include the month name that I got earlier from here. And then I put in a comma and a space, and they have to be in quotes. And then I want to print the year, but the year is a number, not a text string. So I use this function, num2str. So num2 string, it converts a number to a string, a text string. And I have the word has, and then I do the same thing with the days. I convert the numeric variable days to a number, and then I put this text after it to complete the sentence. And then I go ahead and disp that whole string, and that gives me my output. So this is used to have some nicely formatted output that's a little more user-friendly. Any questions about what happened here? Okay,
And this will be uploaded?
but yeah, this one's already uploaded, and I'll be uploading the other ones too. Okay, actually, all right, there are two more that I want to look at. I'll go ahead and put them on this page now. But I should have them. Next, I need to show you for loops. That'll be very important. And then, yeah, I'll still Okay, so now on the main page, Canvas page, you should see two more scripts that you can download.
In there right now.
Okay. Now, for loops. Okay. Alright, so this script, compute me.m, so I'll load it in the editor. Okay.
See it.
Okay. So what does this script do? First, it generates a random vector, 10 rows, 1 column, so it's a column vector. So random numbers uniformly distributed between 0 and 1. And then it's going to display the vector for me using the disp command. And then what it's going to do is compute the mean of all the elements of the vector. Now MATLAB has a function for that, it's called mean, but I want to show it, I'm going to do it the hard way anyway to show you how to write a for loop in MATLAB. So I have a variable called m, little m, that's going to hold the mean of the elements of x. So initially I set it to 0. And what I'm going to do is I'm going to have a for loop that will iterate over all the elements of my vector x and add them up and store the sum in this variable m. And then when I'm done, I'm going to divide by the number of elements, which is 10, and now little m will be my mean, and then I'll display the mean. So that's what the code is doing, but now I need to talk about how a for loop is written. So it's a little different than for loops you've seen in other languages. They start with the keyword for, and you have some variable, in this case I, that's your loop variable, and I'm assigning it this range 1:10. Now, we've seen before that 1:10 is a row vector consisting of all the numbers from integers from 1 to 10. Now, the way MATLAB for loops work is whatever expression you have after the equals, it could be a vector, it could be a matrix, it could be whatever you want. But if it's a matrix, what it will actually do is it'll take every time that you take an iteration through this for loop, it's going to take the next column of this matrix and assign it to your loop variable. And I've actually used this once in a while. Like suppose the expression is not a row vector, but rather it's a full-blown matrix. Then the first time through the loop, your loop variable I would be assigned the first column of the matrix, second time through the second column of the matrix, and so on. Sometimes that can come in handy. It's rather unusual as for loops go, but it can be advantageous. And then you have a body of your loop that carries out these operations during each iteration, and then you have a keyword end to end the for loop, just like if statements also require an end. By the way, you'll notice that I've indented the body of the for loop. Similarly, when in the other code, like the if statements, I'm using indentation also. That's not required, but it's recommended because it makes the code easier to follow. Now, it happens almost every time I look at a student's MATLAB code. They're having some problem, and they show me their code, and I'm like, oh my god, this is so ugly. Because it's formatting is just not there. And I can't really stand to read it until it's formatted in a nice way. Fortunately, there's an easy way to do this. So if I deliberately mess up this code and have it formatted in an unorthodox way. Okay, so
He's just making it ugly.
yeah, to show you how to fix it. Because otherwise, first thing I do when I look at your code is I'm going to fix it. Of course, then I think like, well, why don't I do it? But yeah, so here's what I can do. If I select all this code,
So the M is underneath the parentheses.
well, I have type of random number of spaces. The point is to make the code messy. Okay, it doesn't have to be the same as mine.
It doesn't.
No, it doesn't. No, it's just an example.
Well, I was making it.
Okay.
I miss it when the air was out in this building.
What?
I miss it when the air was out in this building. So cold.
Oh, what? Good question.
Yeah, so apparently you can't really, like, you know how in C++, and I think it applies to Python as well, like you can, whenever you increment values, like there's a not a shortcut, but you don't have, like, you could
Like,
just plus equals, yeah. plus equals.
yeah, those kind of accumulation operators.
Yes.
Unfortunately, not a thing in MATLAB. I know. I really wish it was. Okay. So if your code is messed up, if you select it, there's a button here that's for called Smart Indent. So I can just click this, and there, the code is formatted.
Smart Indent.
Yes. Now there's a keyboard shortcut. So I'll just type this as a prompt just so you'll have it.
Smart Indent.
Okay. So Control
So it returns everything to.
the recommended indentation. So Control I in Windows or Command I on Mac will also form Smart Indent on whatever text you've selected. So often, like when I look at a student's code, I'll do Control A, Control I. Control A to select all the text, Control I to indent it, and then I can stand to look at it. But the thing is, MATLAB helps you with the indentation. So if I were to add a number loop to this, like for I equal 1 to 10, okay, start typing another if statement, for statement, and notice where it puts the cursor. Now that I'm inside the loop, so I'll just display the ith element of the.
So is that why you would have to go fix it?
Right. So like, okay, so now I type this line. Okay, if I can type more here, it'll do it under the disk. But now if I type end, watch what happens. End, it places it in the right column. So it will help you, which makes it all the more amusing that when I finally see code from a student, it's really messed up, even though MATLAB was literally helping them the whole time. So, yeah, it's amusing. Okay, so
You don't like you gotta.
no, because it's not what script's meant to do. If I run the script now, compute mean, okay, it generates random index.
So you erased it and then you went there.
Yes.
Control.
So here it just displays the vector, it computes the mean and prints it out, so it's not very interesting. Okay.
Compute mean. Wait.
Yeah, that's just what I type in the prompt to run it.
So are these variables random?
Yes, they are. Yeah, really back to the code, X is a vector, so a 10 row, 1 column matrix consisting of random values. This is generated by random. Any questions about how to set up a for loop? Well, one more example is going to show you that. For a elaborate example, the last file we're going to look at today, Gaussian elimination, Gauss elim. So I'll open that in the editor. So this is Gaussian elimination that performs row operations on a matrix to reduce it to upper triangular, also known as row echelon form. Those of you who take the next class in the spring will see a lot more of that. But this script is just to demonstrate nested for loops. So what this script does, I set the number of rows and columns, m and n, both equal to 40. So I generate a random m by n matrix. So A is a 40 by 40 matrix. And then I display the matrix and indicate before elimination, because I haven't done any Gaussian elimination on the matrix yet. But then, in this series of nested for loops, we have 1, 2, 3, 4 loops nested within each other. I carry out row operations that come from Gaussian elimination. And once that's finished, then I display the modified matrix. So I'm not going to get too much from the Gaussian elimination process now because it's something that we'll learn about later, those of you who stick it out. But notice here, my outermost loop, I have my loop variable, I call it J, because looping over all the columns for matrix, which are often indexed by J. Going from 1 to n minus 1, where n is 40, the number of columns in the matrix. And then this loop inside of it uses the value of J in determining what values this loop variable will assume. So I assumes all values from J plus 1 all the way up to M. Okay, so this variable ends up being used down here. And then I set up a row operation by computing what's called a multiplier. So I'm dividing elements of a matrix A, Aij divided by Ajj. And then I have this innermost loop, and its job is to subtract row J times the multiplier from row I. And I was thinking this is what you're asking about, how about those accumulation operators. Yeah, it would be nice if we could have had one here, but we don't. Okay. What we do have, or there's actually more than one way to write a loop. So I have to get down here this, I label as equivalent code. This statement right here is equivalent to this loop. So you can actually write in MATLAB you can write a for loop like implicitly. So what I've highlighted here, this is an explicit for loop because it has an actual for statement. But notice here I have k going from j to n. If I take this statement and wherever you see k, I replace it with this same range, j colon n. This is an implicit for loop. So this will accomplish the same thing as this.
You got rid of the percent.
Yeah, just so you can see the syntax coloring. I actually don't want to do both of these. I can do either one. So you can see how here I'm specifying a range of columns for performing the row operation. So just so you know, these two are equivalent. Okay, I'm going to put this back now because to run it, I only want to do one of these. I'll do this one. So you can make your code a little more compact by using these kind of implicit loops. Okay. But when you're just starting out, probably better to use explicit if statements, for loops, that sort of thing, just to get used to things and then you can see how to optimize it. Especially if you don't have that much experience with programming in general. Any questions about what this code is doing before I run it? Okay, so type name the script, else. It's going to generate a lot of output though. Actually, you know what I'll do? It's easier to digest. If you have something that generates pages and pages of output, that could be a pain. Like stop. So I'm going to type this command first. More space on. If you've ever used Unix-like operating systems, the more command pages output, so you can view it one page at a time. So the more command, I'm not sure why we call it more, but whatever, is available here in MATLAB also. So by default, output will just scroll past you, but if you do more on, it'll start paging it. So now I will run the script, galfalin, and even though there's going to be a lot of output, it'll stop. it'll stop after one page. Notice it says more. So here it's starting to display the matrix. It's a 40 by 40 matrix, so first 6 columns. And now it says more down here. So if you were to go to the next page, yes.
All I'm getting is an error. Oh. I typed in the wrong letter.
Oh, okay. All right, good. All right. So now to advance to the next page, you hit the space bar. So I'll hit space bar, and now there'll be
Space bar.
yes. Whereas if I hit the enter key instead, it will advance only one line at a time. So you can advance through the output however you like, either slowly or quickly. So,
Almost done.
we're trying to get through it?
Yeah.
Okay. Now, okay, I want to go through, this is the matrix before we do anything. I want to get through all that. And then I can show you the matrix that we get after. Okay, so we're getting down to the end. Okay.
Mike, are we supposed to continue going?
Let's see, where are you gonna? Oh, hit the space bar. Yeah. Keep going. Keep going. Okay. Okay, you're only column 11 through 20, so keep going. Until the matrix comes to an end. Keep going. Just keep going faster. Okay, column 20. Okay, keep going. Do it a few more times. Okay, now we're to the last column, so keep going. Again. Yes. Again, just a few more times. More. Okay, now you're at the same place that I am. Okay. Sorry, I didn't mean to start really there. Okay. So this is a matrix after Gaussian elimination has been performed. Notice there's a lot of 0 elements. So the idea behind Gaussian elimination is all entries below the main diagonal are supposed to be made 0. And that's what we see here. But notice if I advance this a little bit more, okay, by hitting enter. Okay. Not sure how these blank lines are got in there. Maybe I hit enter too quickly. Notice that
So click enter.
enter advances only one line at a time, whereas spacebar advances one page at a time.
Did you click enter or space?
Okay, here I'm clicking enter. So notice everything moves up by just one. Yeah, so it's going to move the output up very slowly. Whereas if you hit enter, it'll go a whole page at a time, which I don't want to do right now. Okay, I want to call your attention to something. Notice how in these entries down here, most of them just say 0. But there's a few that say something, it's like expressing a different 0, like 0.000. Or here, -0. What's up with that? So these numbers, they're not exactly 0. They're very small, but because of rounding error. Because if you did Gaussian elimination on the given matrix, like on paper using exact arithmetic in as many decimal places as you liked, then yeah, these entries down below would be exactly 0. But here we're using floating point arithmetic, which I'll talk about in the next chapter, where it's limited precision. So there is some rounding error. So these values are small, like maybe on the order of like 10 to the minus 15, something like that. And if I were to keep going, we see there's several more of these. And some are positive, some are negative. So we have
So
-0.
that's also clicking enter?
Yeah, I'm still clicking enter. Okay. So this is something we'll get into more later about how this kind of what's up with this rounding error. But still, it's fairly accurate in this case.
If we wanted to know, since it's not actually 0.
Yeah.
If we wanted to know what it actually was, even though it's clear on paper, it'd be fine.
Yeah.
Would there be a way to figure it out?
I'd like to actually look at it. Actually, I want to do that anyway. Okay, so
How do we stop it?
I'll come to that. Okay, Here, this is, okay, well, let's pick out an entry that is not exactly 0. So here is column 7, this is column 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is row 16, column 8. This is an example of an entry that's supposed to be 0, but isn't exactly. So I'm going to look at that after. Now, okay, if you want to stop viewing this output, there's 2 ways you can do it. I could keep hitting enter or space until I actually come to the end. Or, if I hit Q for quit, that gets me out right now.
Q for quit.
Yeah, and now remaining output is lost, but I didn't want anyway. Okay, now also, if you wanted to stop paging the output, you do more off. Okay. Now, oh wow, I'm almost out of class time. Okay. All right. So if I look at the, so this matrix A is still in my workspace. You see it right here, A, 40 by 40 double. So if I look at a row 16, column 8, let's see what that value is. So it's a pretty small number, as it should be. Whereas if I look at 1 row up, row 15, column 8, it's going to be exactly 0. Which honestly kind of surprised me that there's many exact zeros as there are. It's an 40 by 40 matrix, that's going to be a lot of round up around here. Okay.
Not what I got.
Oh, well, your matrix is different because it's random, and we already saw random numbers are different. Okay, I've come to the end. I'm going to do diary off. Okay, so, well, yeah, just 1 minute left to class anyway. Okay,
How do we save this command window?
I mean, the all this output. Well, it's saved in a diary anyway. You were doing a diary. Otherwise, I could do a copy. I could like copy it, and then paste it into a file. But were you doing a diary? Okay. Well. Oh, but did you do it at the beginning? Can you scroll up? Very top. Oh yeah. So you should have a diary file. Yeah. So everything that you did is saved in that file.
Where?
Oh, okay. So well, you have all this other stuff in your folder. So if you scroll through here, you should be able to find it.
Thank you.
So that's the class.
Yeah.
Tutorial.